In this video, we'll be talking a little bit about different responses for different organ systems. As you already know, our body responds differently to parasympathetic stimuli as it does to sympathetic. As a result, different organ systems will have different effects. They will have different actions on whether or not it is stimulated by the parasympathetic or the sympathetic nervous system. For instance, let's look at the digestive system. In the digestive system, when you are in a parasympathetic state, you will be undergoing plenty of digestion. There will be lots and lots of digestion to get that meal, that food that you just ate, out of your system. This means that we will increase peristalsis. If we flash back to the digestive system, you'll remember that peristalsis is the repetitive contraction and relaxation of the alimentary canal, particularly the esophagus, stomach, and intestines. Peristalsis is like squeezing the toothpaste out of a toothpaste tube and moving the food out of your system. Again, when you are in a rest and digest state, there will be lots of peristalsis. On the other hand, when you are in a sympathetic state or ready to fight or flight, you don't want digestion to be your worries. You don't want to worry about digesting your food when you're fighting an attacker or running away from a bear. You want to spend your energy on your muscles, on your lungs, getting enough energy to punch and hit and attack or possibly flee. So this is not the time to be worrying about digestion. As a result, when you are in a sympathetic state, you're worried about fight or flight. So digestion becomes the least of your worries. As a result, there will be decreased activity. Let's move on to number 2, or the heart. When you are in a parasympathetic state, you're probably reading a book, you might be watching a movie, or maybe you're eating a meal with your friends. In that case, your heart rate is going to slow down. It'll either have no effect or be less than it normally would be. Your heart rate would decrease when you're in a rest and digest mode. In contrast, when you are running away or fighting, your heart rate will most certainly increase. I always think of the sympathetic nervous system as being responsible for emotion, excitement, exercise, embarrassment, or emergency. If it falls under any of these 5 E's, it'll be a sympathetic response. For example, when you're in an emergency, or when you're embarrassed, or when you're exercising, your heart rate will certainly increase. Moving on to number 3, or the liver. With your parasympathetic nervous system, your liver will actually produce no response. There will be absolutely no effect. On the other hand, when we are looking at the sympathetic nervous system, surprisingly, your liver will have an effect. Let's say that we are currently running away from a coyote. If you're running away from a coyote, you definitely want a lot more energy. And where do we get our energy? We get our energy from glucose, which is stored as glycogen in the liver. This means that when you're running away from something or performing exercise, your liver will release glucose into the blood. When you're excited or exercising and you need more energy, you need more ATP, the place to get our energy is from the liver. The liver stores glucose in the form of glycogen, and when it needs to be released, it will secrete it into the bloodstream. Blood vessels in the parasympathetic nervous system will also have no effect. Think about when you are watching TV, or perhaps reading a book, or you might be studying. Are your blood vessels dilating, becoming wider, or constricting, becoming smaller? No, they have no effect. However, when you are in a sympathetic state, your blood vessels will dilate. In the skeletal muscle and in the heart, blood vessels will become wider. They will have a wider diameter, or greater circumference. I noted that blood vessels in the heart and the skeletal muscles will dilate. This is because we want more blood and therefore more oxygen traveling to the skeletal muscle and traveling to the heart. When we're fighting or when we're running away, our muscles need more oxygen. And the only place for them to get oxygen is from the blood vessels. which is why they need to dilate for the heart and the skeletal muscle. However, in fat and skin, we don't need blood to go there in a sympathetic case. In this instance, our blood vessels will constrict. It will constrict for fat and for skin. Our next one is the adrenal medulla. The adrenal medulla is responsible for secreting catecholamines, including epinephrine and norepinephrine. During our parasympathetic state, our adrenal medulla will not be doing anything differently. It will also have no effect. However, when we look at the sympathetic nervous system, our adrenal medulla will be highly active, secreting epinephrine and norepinephrine. Epinephrine is abbreviated into E, and norepinephrine is abbreviated as NE. These two catecholamines are secreted by the adrenal medulla, and they contribute to producing a fight or flight response. Finally, let's take a look at cellular metabolism. In the parasympathetic nervous system, cellular metabolism will have no response, or more specifically, no effect. However, when we look at the sympathetic nervous system, cellular metabolism will really kick it up a notch. When there is an emergency, you definitely want more energy. As a result, our blood sugar will increase. When we increase blood sugar, the sugar will be able to be used to produce ATP, or energy. In addition to this, our metabolic rate will increase in the sympathetic nervous system. As well, our cells will be stimulated to break down fat. And the reason being, fat is very rich in energy, or ATP. We want our cells to do what they can to produce more energy since we're in such a stressed fight or flight case. I'm going to write those on the board. We will increase metabolic rate, increase blood glucose, as well as stimulate our cells to break down or metabolize fat to energy. One thing I should point out is that whenever you see something having no effect, you can probably bet that it's going to be parasympathetic. For instance, the liver, blood vessels, adrenal medulla, and cell metabolism all have no effect in the parasympathetic nervous system. Let's do a quick review of everything. In the digestive system, you will have increased peristalsis or decreased activity, meaning sphincters are constricted. The heart rate will decrease when you're in a rest and digest state, or increase when there's an emergency, when you're exercising, or when you're embarrassed. The liver, blood vessels, adrenal medulla, and cell metabolism have no effect in the parasympathetic nervous system. In a fight or flight scenario, the liver will release glucose into the blood, which comes from glycogen. The glucose will then be used for energy. Blood vessels can do two different things in the sympathetic nervous system depending on where they are. Blood vessels in the heart and skeletal muscles will dilate. They become bigger. However, in the fat and the skin, blood vessels will become smaller. This is because we want to bring more oxygen into the heart and the skeletal muscle. The catecholamines epinephrine and norepinephrine are secreted by the adrenal medulla. This occurs in the sympathetic case. Finally, our cells become very metabolic in the sympathetic nervous system. We will increase our blood glucose, increase our rate of metabolism, and stimulate fat breakdown, because fat is used for energy. That is pretty much it for what I'm going to show you today in terms of differences between the sympathetic and parasympathetic nervous system. However, keep in mind that the autonomic nervous system has many other responses. There are other target organs such as the kidneys, the bladders, different muscles of the eye that also take on different roles depending on whether or not they are stimulated by the parasympathetic or sympathetic nervous system. Again, we need to keep in mind that both of these are autonomic and therefore involuntary. You are not able to control your heart or what your liver is doing. You can't tell your blood vessels to dilate or constrict. They are involuntary or autonomic. I should put a title on this. I hope you guys found this video helpful today. Thanks for watching.